Hey everybody, and welcome back to another fun and exciting geometry class. In today's lesson, we're going to be on page number 275 in your book, 275. You will find 6.9, and we're going to be talking about how to inscribe a square into a circle. Also, we're going to be doing 6.10 in this lesson, and that is on page 276, and that is inscribing a regular hexagon into a circle. So two different inscriptions into circles, and let's go ahead and look down here at the screen, and I've got my little construction website pulled up, and this is called MathPad, mathspad.co.uk, and then it's got some other stuff, but if you go to that one, you can look up their construction tools. Kind of cool place that you can go and you can construct things online. All right, so what we want first is we want to put a circle on our paper. So make sure you get your compass out, and we're going to go ahead and we're going to draw a circle on our paper. All right, so it doesn't matter the size of the circle. We just want to draw a circle. So now what we want to do is we want to get a square inside of that circle. So let's kind of think about some things that we've already talked about. One of those things is that if we could put points on every quarter of the circle, and then we connect those points, that will give us our square. So we've already talked about that, right? So one way that you could do it is just go ahead and grab your straight edge, and really anywhere you want. It doesn't matter. It doesn't have to be straight. I'll try to make mine at least a little bit straight. Is we're just going to draw a diameter through it, okay? And when we do that, when we draw our diameter, if you look, that diameter is going to give us, it's going to cut the circle in half, right? So now we have points on half. Now we need points on the quarter, okay? So that's easy, right? The first 2 points are super simple. And now what we want to do is we want to come back to the compass. I'll change the color here so you can kind of see these. But we want to bisect this line. Now we know that bisecting is going to be right here. So you could also draw a perpendicular through this point. I just think that bisecting is a little bit easier. It's something you might be a little bit more comfortable with. You have to make sure that that is past the halfway point. And then, just make sure that's past the halfway point. And then we're just going to draw our arc up here. And then we will also draw our arc down here at the bottom, and then we're going to switch sides. We're going to come over here to this side, and we're going to do the same thing. We're going to draw our arc. Don't change the distance, the opening of your compass here. We want to make sure that that stays the same, and that is going to give us our X there. X marks the spot, right? And that's where we have to put our line through. So now this is our line. This is going to be another diameter, but this one is going to basically connect a perpendicular line through our center point. And then we'll come through here and we'll try to draw our line. Mine might be off just a little bit. I try to get it as good as I can. It's not too bad. It's just off just a tiny bit. But yours should be a little bit straighter than mine. It's a little bit hard to draw on this computer, but on your pencil and paper it should be a little bit better. So now we have a point here. We've dissected this into quarters. So now all that you want to do is come over here. We'll change the color, but we want to come through and we just want to connect these points out here. Okay, so I'll just connect from here to here, from here to here, and then I'm just going to go all the way around this thing, just connecting the points. And you can do that with a straight edge, obviously. I just saved time by using the straight line tool on the app here. But now we have our square. So that square is inscribed inside of our circle. How did we do it? We drew a diameter, and then we bisected the diameter. Okay, and that gave us the points that we needed. All right, now the next thing that we want to do is we want to go ahead and, again, start with our circle, and we want to inscribe a regular hexagon. This is on page 276. Before we do this, let's talk a little bit about what is a hexagon. So let's kind of think back to some previous lessons. If you want to go back in your book to 6.2, that's where you'll find this, 6.2. And what we're going to talk about is this right here, central angle and the angle of the polygon. So again, how many sides does a hexagon have? It has 6 sides. So our n equals 6. When we plug 6 in here, you get 360 divided by 6 equals 60. Okay? So in other words, our central angle is 60 degrees. That's important to know. Okay? Now, what is our polygon angle? Well, we're going to plug in 6 all through here. So that's going to be 4 times 180, and that's going to be times 6. If we reduce this to a 2 and a 3, that might be a little bit easier. And then we can actually reduce this. 3 goes into here. This goes 60 times. So 2 times 60 equals 120. So our polygon angle is 120 and our central angle is 60. Now that's important to know because we know a couple things about this. When we have our, because we've talked about this in this chapter. So when we have our circle, so I'll just kind of draw a makeshift circle right here, and we have our 60-degree angle right here, for example. If this angle is 60, and then I'm just going to throw a really crazy hexagon in here. It's not going to look right, but 1, 2, 3, 4, 5, 6. Okay, again, terrible. But I want you to see something. This is just kind of a rough drawing for you to understand this. Now, if this is 60 and these right here are 120, right? Because that's the polygon angle is 120. That's the central angle. I want you to see something. How do we get this? We've talked about this. What is this line right here? Well, it's a radius. That's one thing that's important. And it also bisects this angle. If we kind of zoom this up right here, this angle right here, okay? This 120-degree angle, when we make our, when we inscribe our hexagon, this ends up bisecting this. So because of that, that means that, let me change the color, that means this is 60 degrees, and that would mean that this one is bisected as well, and this one is also 60 degrees. So one thing that we have, and we can see pretty clearly from this, now my drawing is terrible, but we have an equilateral triangle. So that means that this radius is going to equal this side, and it's going to equal this side. Why? Because if we have equal angles, then we also have equal sides. So this is a radius, this is a radius, and this distance between here is also a radius. Okay, so now let's go back to our construction. All right, so what we want to do is we want to start off by drawing a radius. All right, so I'll just draw my radius just really anywhere. You can put it anywhere that you want. We'll just kind of leave it right there. Now, you might think, oh, I'm going to draw my other radius over here. No. Let's not do that yet, okay? So we have one radius. So let's think through what we need to do. You say, I need a 60-degree angle right here, so I'm just going to get my protractor out, and I'm just going to measure a 60-degree angle. Well, then you would be cheating, right? Because you can't use a protractor for construction. So let's kind of think through. You might say, well, I need this length right here. I need this length right over here. And now you're talking. Okay, now you're getting warm. So what we figured out when we looked over here, right, that this side, this bottom piece is going to be what? It's going to be a radius. So if you'll come back over here, and if you'll take your compass, all right, and if you'll, let me go ahead and I'll change my color here. And if I will measure my radius, and I'm actually already on the radius because, you know, I have measured this circle. So basically that's my radius, and I can put a point right there. That way that red point will kind of help me. But so I'll go to this red point, and now all I want to do is I want to just measure over here against my circle. I'm going to measure a radius, and look, where that touches right there is my length that I need, and I can just keep doing this all the way around the circle. And as I go around the circle, it's going to keep giving me the distance that I need for where my next point's going to be. Just keep working your way around the circle and putting these little marks. All right, another one needs to go here, and then we'll come up here. Let's go to this one next. And then I'll mark this, and I need one more. And then right there, we'll finish it off. Now, when I go here, this point should be the same to this point over here. Now, yeah, it's pretty close. All right, so now all of my points are the same distance. All right, and now what I want to do is I just want to draw in my hexagon. I don't need any more radii in here. I mean, I could draw all the radii out, but I don't need to. My goal here of this construction is just to draw my hexagon. So I'm just going to connect these outer points out here, go all the way around the circle, and this is going to give me my inscribed hexagon. Okay, so there we go. Now, what do we know about our hexagon? We know a few things, okay? We know just from the math that we've already done, right? We know that these are all going to be 120 degrees. So if you take your protractor, you should be able to figure out that that's 120 degrees. I could put my protractor on here and I could just verify that, just check that. So when I put my protractor on the point over here, I'm on this line, this green line, that's to 0. So I'm on the inside lines, come over here to my other green line, and look there, we're right on 120 degrees. So it looks like this thing, you know, it actually worked. Why did it work? Because the mathematics behind the hexagon. Another thing that we know is if we were to extend these radii out to the points that we've created, we're going to create equilateral triangles. Look, so this is going to be a 60-degree angle, 60-degree angle, 60-degree angle. Now, doesn't this look better than my other drawing, right? Look at my upgrade right here. Okay, so I definitely upgraded going to actually constructing it. But I like to do them kind of just like freehand first to kind of see what I'm doing, and that kind of lets me wrap my mind around what's going on there. So there it is. There is your construction number 26. Something that's kind of cool right there is if you look at construction 27 and 28, you can do this with multiple sides. So we could multiply by 2, and we could do, that was 6 sides, so we could do 12 sides. How would we do that? Well, we would just divide that angle by 2 again. So now instead of a 60-degree angle, we have a 30-degree angle. So we would just have to bisect all those sides, and then you'd have 12 points. You could do it again, get 24. You could continue to make as many shapes as you wanted. Again, this is kind of how they developed pi. If you keep doing that, it's going to keep making your points closer and closer to the circle, and then you're going to form what's called a limit with the circle. I've already talked about that. So that's all I've got for you in this lesson. Hopefully you learned something there. If you missed anything, make sure to slide it back, watch it again. We'll see you later. Have a good one. Bye-bye.